Basics of Statistics, Part 2.
In previous lecture, you learned about the types of variables. In this lecture, you will learn how we describe them. Let's start with categorical variables. Imagine you have a sample group with 37 individuals, and you count 22 females and 15 males, which can be described as proportions or percentages with 59.5% female and 40.5% male. Or we can explain it by ratio, such as male to female ratio or female to male ratio. Pay attention that this is not a percentage. In the same way, we can explain any types of categorical variable by proportions. However, describing continuous variables is a little more complicated. Let's say we measured the weight of everyone in this sample. The first thing we need to determine is whether the weight follows a normal distribution, which we can check using a histogram. A histogram is a graph that shows the distribution of data. The x-axis represents the values of the variable, while the y-axis shows the frequency of each value. This histogram shows a normal distribution. Therefore, we can describe the weight by mean and standard deviation. Normal distribution can also be measured by statistical tests. The mean of the weights can be calculated by dividing the total sum of the weights by the number of samples, which can be written as mu equals sigma x divided by n. And in this sample with sigma x 2220 divided by 37, the mean is equal to 60. Knowing the mean, we can calculate the standard deviation. Let's see how. First, we subtract each weight from the mean and then square the result. Next, by summing these squared differences and dividing by the sample size minus 1, we get the variance. Taking the square root of the variance gives us the standard deviation. Let's say the standard deviation is 5, but how do we interpret these data? As you can see, the mean is located at the center of the curve, where the frequency is also the highest. By adding and subtracting one standard deviation from the mean, we get the values 55 and 65. And by this, we can assume that 68% of population weigh between 55 and 65 kilograms. Now, if we add and subtract another standard deviation, we get 50 and 70 kilograms, and we can assume that 95% of the population falls within this weight range. But what if the data isn't normally distributed, and we can't use the mean and standard deviation? In that case, we should report metric variables using the median and the interquartile range. To find the median, we first sort the data from smallest to largest, then identify the middle number. This gives us the median, meaning 50% of the sample weighs below the median and 50% weighs above it. As you can see, the median represents the 50th percentile here. Next, we can identify the middle value of the two 50% halves. If there's no single middle number, as in this case, we calculate the average of the two middle values, which gives us the 25th and 75th percentiles. Now, by plotting these 5 values on a scale, we can create a box plot, which effectively visualizes the data distribution. In this case, the median is 66, and the interquartile range is between 54.5 and 78.5, meaning 50% of the sample falls within this range. To quickly recap, categorical variables are typically described using proportions or percentages, and sometimes ratios. Continuous variables can be described by the mean and standard deviation if they are normally distributed. If they are not, we use the median and interquartile range or represent them visually with a box plot.
Thank you for watching.